Hello, I'm Steve Johnson, R&D engineer for GPT 300 Incorporated, manufacturers of Demon Carburation. I'd like to welcome you to this instructional video and start out by thanking you and congratulating you on the purchase of the first newly designed carburetor in over 40 years. Demon carburetors have many unique features that make them the perfect choice for the performance enthusiasts such as yourself. Whether it be circle track racing, drag racing, or just getting the most out of your hot rod, these features make the Demon carburetor the carburetor that will give you the edge over your competitors. Let's start out first though by making sure that you've selected the proper carburetor for your application. If you look inside your instruction manual that came with the carburetor, you'll find an application guide. Please make sure that the carburetor you have is the one that's needed for your application. If it isn't, put the carburetor back into the box and return it to your place of purchase for a full credit exchange towards the proper carburetor. This video is divided into two sections. First, we're going to discuss installation and some basic tuning. Secondly, we're going to get into some of the unique features of the King and Race Demon series of carburetors. Make sure that along with this video, you have read and thoroughly understand the instruction manual that was included with the carburetor. This will help assure that you get the very most out of your purchase. If there are any questions that you have that are not covered by the instruction manual or this video, feel free to call the Demon Tech line. The number is 706-864-4712. Due to differences in camshafts, compression ratios, intake manifolds, and other parts of the motor, certain tuning may be necessary on your carburetor to get the very most out of it. It should also be noted that selection of a cam outside of the intended application can make engine tuning and carburetor tuning difficult to impossible. Please make sure that you have selected the proper cam to go with your application. One final note of safety before we get started is to keep in mind that when you're working in the engine compartment of your vehicle, whether it be a truck, a car, or whatever, keep in mind the rotating and moving parts of the engine. It's not a good idea to wear loose clothing or have dangling jewelry that could lead to something getting caught and possibly an injury. So let's keep that in mind. All baseline adjustments are set at the factory during the final assembly stages and double checked during wet flow testing. These settings should allow for the initial startup and warm up of the engine. Along with flow testing, the carburetor is inspected to verify that it operates smoothly and is free of any leaks. However, to assure safety, it is suggested that you re-inspect the throttle and accelerator pump linkage to make sure no damage has occurred during shipping. Keep in mind, initial startup and warm-up of the engine should be performed with the as-delivered settings for idle mixture screw adjustment and closed butterfly position. First thing that we need to check is to make sure that the linkage did not become damaged during handling or shipping. The carburetor should move freely from the closed idle position to wide open throttle and back again smoothly with no hang-ups. When the butterflies are in the wide open position, they should be, I'll turn it around, they should be near parallel to one another and perpendicular to the base plate. The secondaries should not go over center. In other words, go past wide open. The two biggest rules are never use a carburetor that has linkage that does not operate smoothly or that has secondaries that open beyond the wide open position. When the carburetor is in the closed butterfly position, there should be no slop in the accelerator pump linkage. In other words, as the primary or secondary throttle shafts start to move, so should the pump arm. Any slop in there can lead to hesitation when the butterflies begin to open. Of equal importance is the fact that there still be some play or over travel in the linkage when the carburetor is at wide open throttle. There should be a minimum of 15 thousandths travel left in the accelerator pump linkage with the carburetor at wide open throttle. If there is not, there's a risk that the carburetor linkage could bind, and also it can lead to premature wear in the pump cam and the pump arm. Slop in the accelerator pump linkage is easily adjusted by simply using a 3/8 wrench on the bottom of the stud and a 3/8 driver on the lock nut. Simply turn clockwise to shorten or counterclockwise to lengthen. If you have a little bit of bind at wide open throttle, a quick bend to the cam follower with a pair of pliers can take care of that. Road demons, speed demons, and general competition race demons all feature 3 vacuum fittings in the base plate. The large fitting in the rear and the rearmost fitting on the side are connected to direct manifold vacuum. The front fitting on the side is connected to ported or timed vacuum. Keep in mind that any vacuum fitting that is not in use needs to be capped to prevent a vacuum leak that would be detrimental to the carburetor's performance. Now that we've checked our carburetor for any damage that may have occurred during shipping and made a note of all the baseline adjustments, we're ready to install it onto the engine. It's always a good idea to start with the new gasket. It'll help ensure a good seal between the bottom of the carburetor and the intake manifold. Now, this installation is going to use bolts. If we were going to use studs, important note is to make sure that the carburetor slides nicely over the studs. Don't force the carburetor down. If it won't go down easily, check for either a bent or improperly installed stud. We'll go ahead and set our carburetor on top of our gasket. We need to check and make sure that it sits squarely, that it doesn't want to rock. A rocking carburetor is an indication of either a warped intake manifold or a warped spacer, and the problem must be addressed immediately. If you don't take care of that, you're going to have problems getting a good seal between the bottom of the carburetor and the intake manifold. This one's sitting pretty good and square, so I'm going to go ahead and get our fasteners. As I said, we're going to use bolts in this installation. And go ahead and start them. Just want to get them all going down. So they're all kind of started. We can use our socket wrench to pull them down tight. Not tight, but snug, I should say. And we'll work our way around the carburetor. Now this used, as I said, bolts with a flat washer. If we had had an installation that was using studs, we would have wanted to use a flat washer with our nuts. Okay, once we've got them all down, nice and snug, I want to go ahead and tighten them down. Let's get a good recommendation is about 5 to 7 foot-pounds of torque is what it takes to get a good seal. You want to make sure you use a crossing pattern to tighten them. And there we go. Okay, now that we're tightened down good against our intake, we want to make sure that the linkage is still free and not bound up. So let's make sure that it goes from closed butterfly to wide open and back to the closed butterfly position very smoothly. Now that our carburetor is securely installed onto our intake, it's time to hook up the linkage from the throttle linkage from the car to the carburetor. This is a good time to get a friend to come over and help you. The way you need to start this out is to get the pedal depressed firmly against the positive throttle stop. This positive throttle or pedal stop is mandatory. What it does is it prevents over travel of the throttle pedal which can lead to damage at the carburetor. Now, not all floorboards are sufficient positive throttle stops. On a fabricated floor such as this one, the pressure of the driver's foot can cause the floor to flex and lead to the over travel I was just speaking of. So it's very important to have one of these in the car. The damage I was talking about back here can be very serious. And what it leads to is this end plate getting bent and quite possibly hanging the throttle at wide open. And that's not something that anybody wants to have happen. Now we're ready to attach it to the carburetor. With the pedal up against the positive stop, we want to open up the carburetor to wide open throttle. We need to adjust our rod here to make sure that it slips in. That looks pretty good without any interference with the carburetor end plate. Like I say, we got a pretty good slip fit there. Now we'll go ahead, let the throttle close all the way. Go ahead and we'll start our nut. And tighten it up. Okay, now that we've got it good and tight, we want to make sure that it goes from this closed butterfly position to wide open throttle and then back again. And the next step would be to attach the throttle return springs and then perform the same test again. Keep in mind, you should never rely on your base plate to act as your positive throttle stop, nor should you rely on the springs that are located on the throttle shafts to act as your return springs. You always need the secondary set. Now that we have our linkage all hooked up and our carburetor securely mounted to our intake, we're ready to hook up the fuel system. And as always, we have to make sure we do a good job to prevent any leaks, which can certainly lead to fires. If you're installing Demon inlet fittings, use only the sealing washer that is included with the kit. If you're using fittings somewhere in the system that have a pipe thread and you're going to use a thread sealant, you need to make sure to keep the flow path clear of either tape or compound. All Demon carburetors feature 9/16 24 inlets. And if you have a road Demon, you need to make sure you use one of the official 3 kits that are available to bring fuel into that carburetor. One final thing that must be done is to flush any and all lines that were used in the system to make sure they are free of debris so they don't get into the carburetor and plug some of the circuitry or jam in the needle and seat. Keep in mind that after it's all installed, we need to make sure that we check this system for leaks at pressure. To ease in starting, it's a good idea to prime the carburetor first. If you're in a car that has a mechanical fuel system, what you want to do is unhook the ignition, possibly the coil wire, and spin the motor over until the bowls are full of fuel. On a car like this that has an electric system, you want to bump the pump on and off to fill the fuel bowls. An abrupt surge of fuel through the needle and seat can damage the float, and it can lead to flooding, which can of course lead to a fire. So we'll come over here. That should fill our fuel bowls quite nicely. Then before we go ahead and turn the key, we're going to wet the intake. Best way to do that is to come over and press down on the accelerator pump arms a couple times. That'll get some fuel in the intake and it'll make this car start off really easy. When you start the engine for the first time, it's a good idea to have a friend come over. A second set of eyes can be invaluable in spotting fuel leaks or other problems that you might have, even if you can start the engine from the engine compartment. Another good tip is to make sure there is plenty of initial timing in the engine. 10 to 14 degrees takes care of most situations. However, if you've used a larger camshaft, 18 to 20 degrees may be more applicable. Keep in mind, initial timing has an effect on overall timing, and we don't want the motor to detonate. so it may be necessary to get the distributor recurved. We recommend the use of MSD timing components. They offer timing tapes for the balancer and a good timing light that'll make the job simple. If you have any questions regarding the timing of your motor, give the guys at MSD a call and they'll get you what you need to get the job done. We want to set the engine to a fast idle, about 2,000 RPM, during the warm-up phase. If you use your idle speed screw to achieve this RPM, keep in mind how many turns you've put in so you can return it to its initial position. We want to make sure that the engine is warmed up before we do any tuning on the carburetor. We're going to go ahead and start the motor now. On initial startup, it's always a good idea to have someone sitting behind the wheel of the car. It's just a matter of safety, and it's something we strongly recommend. Okay, let's go ahead and start the engine now. If the engine didn't start and idle with the new Demon carburetor, and assuming that we have fuel at the carburetor and spark at the cylinder, there's a few settings that we need to check. We want to take a good look at the idle mixture screw adjustment and the closed butterfly position. Please make note of these settings for later. The first adjustment that we need to check is that of the closed butterfly position. Best way to look at this is to turn the carburetor upside down. If we open the throttle to wide open, you'll notice 4 slots, one in each of the bores, that extend from the main body down into the base plate. These slots are the transfer slots, and they supply the fuel necessary to help the carburetor go from a closed idle position to part throttle. Gasoline carburetors usually need to have about 20 thousandths, or what appears to be a small square, of the transfer slot visible below the bottom edge of the butterfly. Alcohol carburetors need a little different adjustment. They need the bottom of the butterfly to be basically even with the bottom of the transfer slot. It is important to try to keep both the primary and the secondary closed butterfly adjustments pretty much the same. In other words, you don't want a lot of transfer slots showing in the primary and next to none in the secondary. This is sure to lead to a stumble. If you do need to make some changes to the closed butterfly setting, it is done by using the idle speed screw located in the base plate. Turning the screw clockwise will cause the butterflies to open, and counterclockwise will close the butterflies up some. This is the same for both the primary and the secondary throttle shafts. The idle mixture screws are located on either side of the metering block. These screws help to control the amount of fuel that the carburetor supplies to the engine in the closed butterfly and just off closed butterfly positions. To check the initial setting, simply turn the screw in half-turn increments until it bottoms out against the metering block. Return the screw to the delivered setting. Most carburetors require an adjustment of approximately 1.5 turns out from the bottomed out position. All 4 screws should be adjusted the same. Keep in mind, this is just a preliminary adjustment and will need some fine tuning after the engine has reached operating temperature. If your carburetor was not adjusted properly, make the necessary changes and reinstall it on the engine. Once reinstalled, if it still will not start up and idle smoothly, or if the carburetor checked out okay when you went through it, the carburetor is probably not the source of your current frustration. However, Feel free at this point to call the Demon Tech line. Make sure you have your engine specifications handy to help with the troubleshooting. Even though the float level or fuel level has been preset at the factory, I want to go over this adjustment with you real quick. Now, we recommend this adjustment be done with the engine off and with any electric fuel pumps turned off. This is going to reduce the chance of spillage, which could lead to fire. A good initial setting, and the one that comes from the factory, should have the fuel level roughly in the middle of the sight window. It's a good place to start, but experimenting above or below that slightly that's perfectly fine to do. The way you perform this adjustment is using a 5/8 wrench, go down over the adjustment nut, and using either a Phillips or a standard flat blade screwdriver, break the lock screw loose. A turn of the adjusting nut clockwise will lower our float level, whereas counterclockwise will raise it. When you get it to where you want, go ahead and lock the lock screw back down, and we're sure that we won't have any leaks. Now, it's a good idea to only loosen the lock screw as much as necessary to prevent any excess fuel from coming out, and it just further reduces the chance of there being a fire. Now, if your adjustment was to increase the float level, you'll notice that immediately as soon as you turn the fuel pump back on or start the engine. However, if your adjustment was to lower the float level, you're going to have to wait until the engine has run a little bit to go ahead and burn off that excess fuel that is above the new setting. One final note, we do not recommend the use of the nylon needle and seat gaskets. They're a good bit thicker than the paper or gasket material ones, and they limit the range of adjustability you're going to have with the needle and seat. We're now ready to set our idle mixture screws. This is an adjustment that would need to be done with the engine running. However, since this car is pretty loud, we're going to go ahead and go through it with the engine off. But keep in mind, you'd need to perform this with your engine running. You'll remember that we got the water temperature up to about 160. And the one thing we need to make sure is that our butterflies are back to their initial closed position. Some of you may have used the idle speed screw to achieve the 2,000 RPM that was necessary to warm up the motor, so return them back to their initial setting. One thing before we start that we need to make sure that we're aware of is that at idle, there should be no fuel coming from the boosters. If there is fuel coming out of the booster, it's generally the result of one of three things. Either one, our float level is too high, two, our butterflies are still open too much. That generally results in a pretty high idle though. Or three, the fuel pressure is too high. We need to get this corrected before we can accurately adjust our idle mixture screws. If the engine started easily, idles smoothly at an acceptable RPM, produces a clean exhaust and has no off-idle stumble, we suggest you leave the idle mixture screws at their current adjustment. If this is not the case, we need to do some tuning. A black sooty exhaust is an indication of an over-rich idle circuit. To correct this, we're going to turn each of the 4 idle mixture screws in 1/8 to 1/4 of a turn until the exhaust cleans up. We will use our idle speed screw to readjust to the desired idle RPM. If we have a clean exhaust and no off-idle stumble, we're in good shape. If the exhaust is clean but there is an off-idle stumble, it's an indication of a lean idle circuit. To correct this, we want to turn each of the 4 idle mixture screws out 1/8 to 1/4 of a turn. We will continue this process until the stumble goes away, again using the idle speed screw to adjust the idle RPM. Most tune-ups will require an adjustment of between 1 and 2.5 turns out from the bottom position against the metering block. If your final tune-up results in an adjustment that is outside of this range, but the vehicle starts easily, idles smoothly, has a clean exhaust and no off-idle stumble, that's okay. If you cannot achieve this type of operation though, you may need to make further modifications to your idle circuit. If the carburetor still seems lean, but came equipped with additional idle air bleeds, we need to go ahead and remove the carburetor from the intake. Take one of the bleeds, and on the primary side of the carburetor, outermost bleed, insert it. If it's screw in, you'll screw the bleed in. These happen to be press in, so we're going to tap them into place and then repeat that process on the other side on the primary. Return the carburetor now to the intake manifold and see if it's improved our idle situation. If it has, we're done. If it hasn't, remove the carburetor a second time and install the bleeds in the outermost two bleed bosses on the secondary side. This should take care of any of our idle problems. If your carburetor did not come equipped with an additional set of idle bleeds, you need to go ahead and contact a Demon Tech representative for consulting on what air bleed or idle feed restrictor modifications you're going to need to make for your application. If you're troubled with a high idle that you can't seem to get rid of, it's an indication that the idle circuit is lean. There's two quick tests to prove that. One, take a toothpick with a round tip and insert it into one of the idle air bleeds. If this causes the RPM to drop, the circuit was lean. If a toothpick isn't handy, you can depress on the accelerator pump arms and deliver a shot from the squirter. If this excess fuel causes the RPM to drop, again, the circuit was lean. An engine that seems to float from a higher RPM on its way back to idle is another indication of a lean idle circuit. There's two other hints I'd like to give you when tuning on a carburetor. One, it is necessary to keep the air bleed area clean. WD-40 is a great tool to blast any debris out of this area. This will help not only with idle, but with the performance of the carburetor through the entire range. One other thing to keep in mind is that the bowl screws will need to periodically be snugged up. This will help keep the carburetor sealed up properly. A good rule of thumb is to check these every time that you change oil. The squirter is another component that plays a key role in whether or not a carburetor has a stumble. The squirter is located between the air bleed bosses on both primary and secondary if it is a mechanical secondary carburetor, and only on the primary if it's a vacuum secondary carburetor. The squirter delivers fuel from the accelerator pump during quick throttle position changes to help compensate for the quick increase in airflow. Squirters all come with a rating. There's a number on them that is representative of the orifice size located in each leg. The larger the number on the squirter, the larger the orifice is in the legs, and the quicker it will deliver the pump shot. A squirter with a smaller rating stamped into it has a small orifice in the legs and will deliver a longer, more prolonged pump shot. Squirter removal is easy. Simply remove the squirter screw and take the squirter away. Keep in mind it has a gasket on the bottom of it and on the top of it that are necessary for it to seal properly. To install a squirter, you simply reverse the removal process and screw it down till it's tight. Good carburetor performance is reliant upon having a good, adequate fuel system. Gasoline carburetors require between 6 and 7.5 psi at idle and full throttle. Alcohol carburetors perform best with 3 to 4 psi of fuel pressure at idle and around 9 to 11 at full throttle. Failure to maintain adequate fuel pressures not only can hurt your performance, but can also lead to engine damage. That's why Demon Carburation recommends the use of BG Fuel Systems fuel delivery components. They offer a complete line of pumps, regulators, and filters for all your fuel system needs. You can call 706-864-8544 to get the address of the dealer nearest you. A good way to determine if your fuel system is adequate is to do the 1 gallon can test. What you need to do is go purchase a 1 gallon gas can from your local hardware store or auto parts store and cut a hole in it large enough to fit the lines from your regulator into the can. Due to the fact we're going to fill this can and there may be some overage or spillage, I suggest you take your 1 gallon can that's been cut and place it inside of a larger bucket to contain any possible spills. You now take your regulator, which has been set to the proper operating pressure for your application, and insert the regulator lines into the can. But I first want to talk about setting a regulator. Most fuel systems require the pressure to be set with the engine at idle. Setting a dead-headed regulator, or one that has no flow coming out of it, leads to an inaccurate reading that is useless. So keep in mind, when you set your regulator, you want your engine running. Now, the best way to do this test is to have 2 people, one holding these lines and one running the fuel pump. We're going to take our lines now and hold it into the can. We would then have our buddy turn the fuel pump on, and we would time how long it took to fill this 1 gallon can. Now, if you've got a car that runs in the 12s, you should be able to fill that can in less than 35 seconds. If you've got an 11-second car, you need to be able to do it in less than 30 seconds. A 10-second car should fill the can in less than 25 seconds. A 9-second car in less than 20 seconds. An 8-second car in less than 15 seconds. And if you've got a 7-second car, you need to be able to fill that can in less than 12 seconds. One other thing that you want to make sure you keep on hand when you're performing this test is a fire extinguisher. Hopefully you won't need it, but if there's any incidences, it's good to have it nearby. I'd like to take this time to clear up a few things. We chose to use this dragster to show the installation and basic tuning due to the increased ability to see the installation. The steps we performed on this race car are the same steps that would apply to your hot rod or your race car. I just wanted to make sure everybody understood that. A Demon carburetor is not a Holley carburetor, though many of the conventional 4-barrel components are interchangeable between the 2 brands. And finally, of all the parts we've talked about, a fuel filter is extremely important to include in your system. This filter can prevent trash from getting into the needle and seat area, which can lead to that sticking, flooding, and the possible potential for fire. So no matter what the situation, make sure that a filter is included in your system. This concludes the basic tuning and installation portion of this video. It's time for you to go out, enjoy the new Demon carburetor, and the increased performance it's going to bring to you. You can turn off the tape now or continue to watch. The second section is going to deal with advanced tuning and some of the unique features found in the King and Race Demon series of carburetors. If you turn off the tape now, or if you have any further questions in the future, please don't hesitate to call the Demon Tech line at 706-864-4712. Both the King and Race Demon RS carburetors feature removable Venturi sleeves. Having the proper size Venturi helps create the proper depression, which will pull the right amount of fuel out for your application. In either case, to remove the sleeves, you need to turn the carburetor over and remove the screws, 6 in each case, that hold the base plate into position. With the screws out, the base plate is now free, and you can remove it from the bottom of the carburetor. The next step is to remove the gasket and set it off to the side. The sleeves will now slide out the bottom of the carburetor. Note that on the Race Demon RS, there are flats which orient against one another and that helps position the sleeve properly into the center section. As mentioned before, sleeve removal on the King Demon is basically the same as the RS. You need to remove the base plate, and then the sleeves will come out the bottom. But there's two extra steps you have to do. You need to remove the fuel bowl and metering block to gain access to the metering block face. Here you'll find a bleed that holds the intermediate tube in, one in each bore. If you remove the bleed, the intermediate tube will slip out and the sleeve will fall out the bottom. If you'll remember, there were notches that oriented the Race Demon sleeves. King Demon sleeves are left or right. This is due to the fact that the intermediate tube is slightly off-center. Please keep this in mind upon reinstallation of a King Demon sleeve. Both Race Demons and King Demons feature removable boosters. In either case, the first step is to remove the fuel bowl and metering block from the side of the carburetor. If you're going to work with a Race Demon, you need the Race Demon booster removal tool. Simply insert it into the booster retention nut, turn the nut counterclockwise, and the booster comes out. If it's a Race Demon RS, you need to make sure that the removable Venturi sleeve is out of the carburetor before you try to get the booster out. The technique with the King Demon is a little different. It requires a slide hammer. You insert the slide hammer into the stake tube that retains the booster into the carburetor. Once it's in, good tug, the stake tube will come out. If it's a King Demon RS, you can get the booster out even if the sleeves are still in the carburetor. To reinstall a booster into these carburetors, you simply reverse the steps we've just done. With the King Demon, add a little bit of Loctite to the stake tube. All Demon metering blocks are made of billet aluminum. This eliminates a lot of the problems that can be caused by the porosity found in castings. There are basically two styles. There's a 2-circuit block and a 3-circuit block. 2-circuit blocks are used on Race Demons, Speed Demons, and Road Demons. The 3-circuit block is used on the King Demon. 2-circuit blocks feature an idle circuit and a main circuit. 3-circuit blocks have those same two circuits but have an additional intermediate circuit. The metering block controls the flow of fuel and the quality of the fuel through the carburetor delivered by the main body and the boosters. This is done through a series of restrictions and passages. These restrictions include the idle feed restrictor, the emulsion bleeds, power valve channel restrictor, and main well jets. The idle feed restrictor controls the amount of fuel that is introduced into the idle circuit. The emulsion bleeds control the job of mixing air with the fuel to give a homogenized mixture at the booster. These bleeds work in conjunction with the air bleeds that are found in the main body. Power valve channel restrictor controls the amount of fuel introduced by the carburetor when the power valves open. The main well jets do the job of controlling the total amount of fuel that the carburetor is capable of moving. In a sense, the emulsion bleeds help shape the fuel curve. The main well jets position the fuel curve. The locations of these devices differ in the blocks. Consult your instruction manual to determine where they're at in your particular block, but in all cases their function is the same. In order to change main well jets, we must first remove the fuel bowl from the carburetor. There we will find the jets along the bottom of the metering block. To remove the jet, we simply use the jet removal tool, spin it counterclockwise, until the jet comes out. All jets are marked with a value. The greater the value on the side, the greater the capability of flow that jet has. Another device that controls flow of fuel in the carburetor is the power valve. Find it on the other side of the metering block. Power valves are also marked with a rating. This rating is an indication of how much load is required for the power valve to open and allow the enrichment of fuel. It is important to have a power valve that is rated at a value lower than the amount of vacuum that your engine produces at idle. This concludes the advanced tuning section of our video. I'd like to close with just a few points though. Due to the increased efficiency of Demon carburetors, you will find if you do any dyno work that the brake-specific fuel consumption numbers are going to be lower. That's just fine. That's where a Demon carburetor works the best. A couple other things. We talked before about how important an adequate fuel system was to assure the best possible performance out of your carburetor. Well, an adequate installation is equally important. If you're in a drag race car, for example, that has a hood scoop, it is necessary to seal the carburetor off into the hood scoop and also put some form of a wall at the back of the scoop. If you're in a dirt car or any type of off-road vehicle that has an air cleaner that protrudes from the hood, it's a good idea to put a dirt shield in front of the air cleaner. This will stop dirt from getting packed on the front of the air cleaner, which can restrict the flow of air into the carburetor. And if you've got a street rod, it's a good idea to make sure that whatever air cleaner you use, you maintain at least 2 inches above the top of the carburetor to allow a good flow path of air. I hope this video has been helpful to you, and I'm sure that there's still more questions that you might have. If that's the case, don't hesitate to call the Demon Tech line at 706-864-4712. Enjoy your carburetor, and thanks a lot.